Welcome to Foo Café and Forefront Consulting. Today we're going to talk about mainly BigQuery. So it's going to be exciting talk by Christian. Let's see if I can get this going. First of all, I'm doing this introduction. It's my role at Forefront is I'm head of data and analytics and also a head of sustainability at Forefront. And I'm glad to be here to introduce us and BigQuery and Christian to you. Christian is a senior cloud architect, and he has been involved in several of our GCP or Google assignments that we're running at our customers. Have you heard about the Swedish moguls? Do you know what the mogul ski team, what do you call it? Moguls ski team. I have no idea if that's correct to say in English. It's Puckelpist in Swedish. It's a team that is up and coming. Maybe you noticed that we took an Olympic gold medal this year. And it's a team that has been fighting really hard and has a strong drive. And it's a team that we at Forefront are very proud to be the head sponsor of. And we're quite similar as a company, actually. We're an IT consultancy firm, and we have a very strong drive and a very strong culture. And you can tell by, for example, the way we work with sustainability. We work with Agenda 2030 as a framework, and we try to even more focus on how we can help our customers in the sustainability area. And we do this together with our partners. And our primary partners, tech partners, are Google and Microsoft. And today we're focusing on Google, as I said. We also work a lot with remote. Everybody did, I guess, during the pandemic, worked remote. We did that before the pandemic, and we still do. Trying to be sustainable in every way possible. And the customers, you're going to hear about one customer today. We're going to talk a little bit about ICA and the case that we're doing there. As an example, we're also including other customers that we have in finance and in telecom. So you're going to get, what do you call it? Real life, what do you call it, Christian? Real life cases. And if you look at data, so what are people talking about? Well, data, of course. But when it comes to data right now, people and in the tech business and our partners are talking a lot about combining marketing data with business data. And Google are doing this, and they're labeling it the customer data platform. And they're of course, Google is very well prepared for this because they have the marketing platform and they have the cloud platform. And they also have this built-in security. And this is part of what Christian is also going to talk about. And if you dig down a little bit into the cloud platform, they talk about smart analytics. And there you have the services and the products related to analytics. And in the heart of that, you have BigQuery. And I promise you that's what we're going to focus on today. But looking at the roles that is required or are required when you work with any platform, data platform, you can see that there is, what do you call it, a red line or a red thread. What do you call that? Röda tråden. And that is BigQuery. Everybody needs to know BigQuery to be successful in this. So, Christian.
Excellent.
Now I'm the ready.
Yes, I'm gonna start with giving like a bit of a background, like why we need to go to the cloud in the first place when dealing with like these modern data challenges, and then also why I think Google is an excellent choice for doing this. But if we look sort of on the traditional side, so what we see is that there was an animation there. Yeah, if we see on the traditional side, we see that the data is growing rapidly. And the traditional sort of data warehouses have a really big challenge in sort of being able to deal with this growing data. And a lot of it is because, as Agneta mentioned, there is a drive to sort of combine like different data sets. You have your traditional data warehouse, but you also have a lot of analytics data, you have ERP data, you have a lot of data coming from customers. And then trying to build on top of that, it just sort of explodes. And some of the challenges that we see with customers is that, of course, the traditional systems, they don't scale very well. They become like more and more difficult to manage. They become expensive. The licensing is sort of growing out of hand. And then you have like the drive from the company to sort of go from just having simple reports into having more like real-time insights, or maybe they want to dip the toes into AI and machine learning and start to build like models on this data. Then the traditional data warehouses struggle quite a lot with that because of these challenges. And also like a general thing, if there is something that you want to know more about or have any questions while I'm presenting, just feel free to interrupt me, and we can have it a bit of interactive. But if we look at the data warehouse side, both Gartner and Forrester has sort of nominated Google as one of the leaders in this journey. Because to overcome these challenges that we have in the traditional data warehouses, the sort of the natural progression there is to move into the cloud, and there's a lot of different options there. But if we look at Google, I think they have a really strong sort of offering compared to the other cloud vendors out there. And what we see is sort of the mindset of the customers. What they really like about Google is that it is like this complete ecosystem. There you have the BigQuery that we mentioned briefly at the core, but then you have a big ecosystem with services that support it, like all the way from ingesting the data and working with the data, and then also getting the data and the insights out of the GCP. And Google, they build stuff sort of on a planet scale, so they handle the load. You can scale it up to hundreds of terabytes. It's like no challenge. And a lot of that depends on sort of that these technologies that we get to use at Google, these are the same that they use internally. So these are the same platforms and tools that Google use, to analyze the data from YouTube and Gmail and all of that. And Google also has a culture of using open standards, even though like these BigQuery and other services are of course sort of closed down, but they're very open with writing white papers and talking about the technologies they use. And there's also a lot of open integrations with these technologies that Google has. And they're very open to working with partners to get the partner solutions sort of integrated with GCP. And an important sort of foundation that Google has with the data is that, of course, everything you put into Google, it's your data. So it's built around that. So they're trying to build this trust, not only in the way they're sort of promising you, but they're also building technology around this to make sure that the data is safe. So they even protect against like insider access. So even the Google employees and engineers themselves, they can't just access your data. And they also work a lot with tooling and sort of to help with the compliance and guidelines and making sure that, for example, governments shouldn't just be able to access data as well. But that's very important to think about. When looking at the cloud journey, like regardless of we're talking on-prem or in the cloud and so on, you have like these traditional steps. You're collecting the data, you're storing the data and processing it, and you're analyzing it. And now, like the last few years, we're also, using AI and machine learning to get some insights out of it. But what I see, like the big change, and one of the sort of challenges that companies have, is that you have like these great tools from Google or Azure or like any other like cloud platform, but that's just a small piece of the building blocks. So even like just technology won't solve like these challenges with big data and AI. There also needs to be a very big like cultural element as well all the way through it. And that's like a lot of the cases and customers that we work with, we see that as like one of the biggest challenges that you have. You still have the traditional mindset from the data warehouses that you have on-prem, and then you're trying to use the same sort of mindset and the same like working the same way as usual in the cloud, and then it doesn't really give you the benefit. And another big part is of course the governance and control over the data. Because moving the data into the cloud, and especially in Google is an American company, and we have like really tight, privacy regulations here in the EU. So that also means you need to take a lot of responsibility, and you need to build a lot of safeguards to be able to use these technologies. Because it's one thing to move things into the cloud, but to be able to use the data and get the insights and build on top of it, you need to be, of course, confident that you are also compliant with all the regulations. And that is something that Google has worked quite a lot on, like the last 2 years, and that's one of the areas within Google that is growing the quickest. So they're helping customers with tools and best practices and different ways to make sure that we stay compliant. But also on the data culture side, to sort of more focus on the data and see the tools more as a something around it. And one thing that reflects this is that we see that the data engineer and the data scientists, like their traditional role is sort of changing as well to be able to work with these new technologies. The traditional sort of platforms, you got like everything out of the box, like, maybe a nice graphical user interface, and you just dragged and dropped and connected some things, and you got like a nice and pretty report. But to use like the real capabilities of the cloud, you need to sort of build it yourself. You're just getting a lot of building blocks. You're getting like this big toolbox with different components and building blocks. But you need to put them together yourself to be able to get something useful. So, for example, to just get certified as a data engineer at Google, there's a vast piece of technologies that they want you to master. But not only that, it's also a lot of soft skills that needs to be involved, because it's not just enough to be a cloud architect and work on your corner or be a data architect and work on the data. You need to understand the entire tool chain, and you also need to understand the end users. You need to understand like the data owners, and you need to understand quite a lot. So I see like the data engineer almost becomes like this new rock star in the organizations, because they are really like driving this change. And the better they get at sort of getting into this new culture, like the more benefit the companies can get as well. But let's continue to BigQuery, because I think BigQuery is sort of the killer application in Google. So it's a serverless platform where you can put a lot of data. You can make a lot of big queries, as the name suggests. And it's also integrated with almost every other component in the Google ecosystem. But not only that, they also have support for multi-cloud, so that you can integrate with data maybe you have on-prem or in other data sources as well. And it's built to be secure and also to be sort of scaling and manage pretty much anything you can throw at it. Just as an example, like if you have Spotify, this sort of thing you get at the end of the year with all the insights and everything, that's an example of one of this like big loads that BigQuery can handle. And it is completely serverless. You don't get your own sort of BigQuery instance to work with. So you just enable BigQuery, and you can just throw in data into it. You don't need to scale it or deal with anything like that. You can put a gigabyte in there. You can put a petabyte in there. It can handle it. And also, like most critically, is that the performance doesn't degrade. So with the traditional warehouse, like if you double the amount of data, then of course the queries and the performance is also going to go down because it needs to process more data. That's not the case with BigQuery. And we're going to look into sort of why that is and sort of how it works behind the scene. So BigQuery, it's sort of divided into two different components. You have the storage. So it's built to store data efficiently and scalable, and that's the same sort of storage solution that Google has for a lot of their other services that sort of store a lot of data. And then you have the compute side of it. So that's the sort of the cluster that makes these, that run these queries. And the programming language for this is normal SQL. So you write the queries and the jobs in SQL. But that's also a trap, especially if you're coming from the traditional warehouse, because it just feels like a SQL database. So just looking at it quickly, it has like all that, all the same sort of capabilities. You write, your normal SQL queries, but it's not a SQL database. So it's more like a computing platform that can run like really big jobs. But you can also integrate BigQuery into other things. You have the REST APIs, and you have a lot of tools. It also has a really good web UI, so that you can make the queries and look into the data. And it's also, open source libraries available for almost every major language. And one of the biggest sort of difference, if you compare it to a traditional SQL database, is that in a SQL database, it's focused on the rows. So you have a lot of rows in your database, and you can lock a row, and it's like atomic, and it's you have all these nice features. But that is also the features that make SQL sort of slow when you put a lot of data into it. In Google and in BigQuery, data is stored in columns. We might look into that a bit further on if we have time to sort of see how to deal with that. But the benefit of using this column storage is that it scales much better. It has the downsides that the normal things that you're used to in SQL doesn't work the same way anymore, because you can't lock like a row, you can't use transactions, and you can't use like a lot of the things you're used to, or at least they don't work the way you expect. And if you don't have the mindset, and you don't sort of learn like these sort of differences, it might feel like this is broken, like it doesn't work the same that it used to do like before. But then understanding like why it is this way, because there is a reason, of course, and that is so that it can scale. So looking into what happens like when you make the query. So you write your nice SQL query. Google actually compiles that into a job. So compared to a traditional SQL database, like it's the database server, it sort of reads your query and then sort of executes it and goes through the data and gives you a result. In Google, it takes the SQL and compile it into a job that is running, and then that job is distributed on a lot of different compute nodes in parallel. So that's sort of the way it can scale. So if you have a lot of data, then of course there will be a lot of workers that take one piece of the data each. And then instead of just giving you the result back, it creates a new table for you. And then all these different workers, they store like their piece of the result into this table. So that's like how it can like do these really big queries. Like even if you have, 1 billion lines of data in the database, it can still sort of perform and scale. And when we're looking at our partners and customers, like the biggest sort of problems they have with this is, of course, you don't have any indexes or keys in the table because the data is not stored as lines, so it can't sort of work with the line as a unit. And like one of the downsides of that is that it's very easy to get like duplicate data, especially if you're ingesting data from a system. So maybe there is like a disruption, maybe the network goes down and so on. Then you can very easily get a copy. So you have 2 rows. And for example, working with transactional data or like money transactions, like if you sum the total there, it's not going to be good anymore. And then that also feels like, oh, this is broken. It's like why can't it just have a unique key? But again, like that's a side effect of the choices, the architectural choices that Google made to be able to create this really big scalable solution. And there are ways around it. One way is to sort of embrace it. Just let the duplicates be there, and then you can use like a view, like a SQL view that filters away those ones, like when you're going to work with the data. Another thing is that in a traditional sort of data warehouse, you have like your golden data, and then you build like a lot of complexity and models on top of it. But for BigQuery, that is trying to do like break it down into small, simple like tasks, having this like really big, complex data becomes very difficult for Google to scale. So what you really should like embrace is this data duplication. So instead of having like your master data stored, maybe you should have like 10 copies of the data stored, but organized in different ways, and maybe pre-computed and so on. Because one thing in Google is that storage is very cheap, but computing is very expensive. So it's like a way to get a lot of better performance, but also, of course, lower cost is to have copies of the data. And also, like in a normal database, so like I would say like a traditional SQL database, you can also do like updates and deletes. You have your record like with a customer, for example, and you update it using SQL. That works in BigQuery, but the performance is horrible. Because then like it needs to synchronize all these different workers, and you need to do a lot of work to get that working. So what you can do instead is to sort of insert a row where you describe the change. So instead of updating an existing record, you can just put another record where you sort of tell it like, oh, the address of this customer has changed to this, and then you can create a view that sort of combines all the different records for that one. So to get the best performance, it's actually just to insert data, to not delete data, not update data, but you just insert more and more data into BigQuery, and then you get like really good performance, and also avoiding the complex structures. And I also see the data engineers and the data scientists that really grasp this concept of a distributed job that is running. They can also get the most benefit out of the platform, both in terms of performance but also in costs. And this is like a really, really big topic. Normally, I also do training for some of our customers, and normally this sort of topic that we're talking about now, it's a two-day course that I'm trying to condense into 40 minutes. So what we have as a suggestion, if you take out your phones and if you have a QR reader, we have 3 different topics to sort of deep dive a bit deeper into BigQuery. So the 3 topics is more of, the first one is to learn more about the different structures, like different layers, and sort of how to build things in BigQuery. And then there's one with cost, sort of what drives the cost and how can you build things to sort of make them cost efficient. And the last one is regarding security, and also with compliance and GDPR, and sort of how to work with PII data, for example, in BigQuery. After the pizza, if there is an interest, there's also the possibility that we can go back to some of the slides if you stay after the pizza, and we can look at the other topics as well. Are you keeping track, Agneta? A clear winner. That's good. So it's the next one, so I don't have to search for the slides. Yes, so it's the structure, sort of how does the different layers and how are things sort of stored, and how do you organize things in BigQuery. We're also going to look into a bit more about this column-based to see sort of how things are stored. So in the bottom, we have this distributed storage that I had like one of the other slides where I showed the storage and the compute. So on the storage is built to handle petabytes of data. That's nothing you need to allocate, or you can just put the data in there. If you're going to put more than like 100 petabytes, then you might need to give Google a call first so they can make sure they have the capacity in that data center. But usually it's not an issue. And on top of that, you can partition your data. So you can sort of segment the data to make it a bit more efficient. So that could be, for example, to store the data for every day separately. And there's also something called clustering. We're going to look at those concepts briefly here in a while. So those are concerning performance and costs. And then on top of that, you can use something called a materialized view, and that's quite new in GCP. So a normal view in SQL is, of course, you write a query, and then you can get the result, and it behaves almost like its own table. A materialized view is actually where Google stores the result. So instead of you making a view and where it sort of executes a query, Google has already executed a query, so the result is already there. And then you can sort of select that, do you want it to be updated like every minute, every hour, and so on. But it can also do it in real time, so it can sense that the original data is changed. Then it can update this data in the materialized view. So that's a way to get a lot of performance out of it. And as you see, it's optimized for different sort of amounts of data. So these materialized views, they are perfect for up to 10 terabytes of data. And then on top of that, there is also a really new thing. It went general availability in Google, I think, this last year. It's called BI Engine. So that's a memory-based sort of cache that you can put in front of BigQuery, where it can sort of, using machine learning and sort of adapting to the kinds of queries you're making, it can sort of optimize data and load it into memory. And that way you can get, sub-second results from queries. Because that's also a thing to note, like the further down we go here, the slower it is. So when you're querying this big storage, just for the query to spin up, it can take several seconds. But the good thing is that it's still several seconds if you put a ton of data in there. Google has a lot of data sets available to play around with. One of them is a copy of Wikipedia. So all the data in Wikipedia is available in this data set. I don't know if you see there, but it's two identical queries. So they're selecting, like, they're summing the amount of views on BigQuery for a specific date in a specific language and in a specific topic in Wikipedia. So it's the same query. The only difference here is that it's structured differently. So it's a table containing the same data but with different structure. So the first query, it took 20 seconds, and it processed 2.2 terabytes, and the result was only these two rows. The other query, the same data, same results, same query, but this time it only took 5 seconds and processed 200 gigabytes. So knowing like these different capabilities in BigQuery is quite important, because it's one thing to wait 4 times longer for the result, but you also need to pay for this processing, because here it needed to, like, these different jobs that process the query, they had to go through 2.2 terabytes in this case, and you have to pay for all of that. I'm going to show you the difference, but the difference is this one is partitioned, so that was one of the different levels, but this one is partitioned and clustered. So I'm going to show you what that is. So normally, if you're creating a table, and you're using SQL, again, because BigQuery is SQL compatible, so you're creating these different columns, and then BigQuery creates a storage for each of these columns to put the data that you put in there. So when you're selecting from this storage, you're just selecting everything for a specific date. Then these workers need to scan all columns to sort of get you this result, even if it's only one line. Like, the workers don't know that, so they're just taking a chunk of the data each and processing it. So you need to pay for all of the data. So maybe you have like a petabyte of data here, then you have to pay for that. So it's about the processing data that you pay for and not the result. So what you can do is you can partition. So what the partition does, it almost creates like hidden tables. So instead of you having like a really big table with all of the data, it can create like a lot of small tables in the background. The queries still look the same after that, but then it sort of slices these columns. So in this case, we did it on a date. So that means that for every day, it will create a new table in the background. So if you're storing, a record for a specific date, it will almost have, its own storage in Google. It doesn't cost anything more because it's still the amount of data that you store. But the difference is that your query, because this sort of limits on this sort of dimension that we did a partition on, then Google knows that it only needs to scan those partitions, and you only pay for that. So that's a way to cut the cost, enormously. And then we have a last, another level, and that is called a cluster. And it's quite simple actually. So it means that it sorts the data in the column on that field. So in this case, we're clustering by user. So that means that it stores the users. They are stored like alphabetically. So it just tells Google like how to store the data, and that also means that if you have a lot of servers, the data with the same user, they will sort of be stored almost on the same disks. So that means that it's very close, like physically. So when you're making a query on this, then it can sort of quickly find it in this column. Instead of having to scan the entire column, it can just find it on the right order. So then you can get like all the data for a specific user very quickly because it doesn't need to look all over the place. This is also something that doesn't cost anything. Yeah, go ahead.
Thank you. Just wondering, does it come with any penalty or cost to partition in the first place? Otherwise, wouldn't you just want to partition on everything so that you have everything partitioned and ready?
That's a good question. So on partitioning, you can only do it on one dimension in a table. And once you've done it, you can't change it. So it's sort of like a permanent thing that you're doing. So that's also going back to this having the copies of the data, because that means that you can have one table with the data partition on one dimension, and then you can have a copy that is partitioned on another dimension. So that's a way you can sort of get around it. When it comes to clustering, you can do, I think it's 4 or 5 levels. So it's sort of sorted first on this column and then on this column and so on.
You wouldn't want to partition on every user, for example, so that you can quickly look up a user if you need to?
You could. It depends on sort of how the queries work, because it's also like a trap that you can fall into is that you partition on like a cluster on a really bad value, and then you get something called a hotspotting. So for example, if you don't have a lot of entropy in that field, so maybe you partitioned on, I don't know, country, and you only have Swedish customers, then it will try and put all the data, like the clusters will come too big. So it's also like a bit of a finesse, like finding good sort of dimensions to cluster and partition on. Google has sort of a rule of thumb. So for a partition, each partition should be around 1 gigabyte of data at least for it to make sense. But good question. So going back then to the query, because we have the where with event date, so it can pick the right partition in these columns, and then we have the user Mira, and we have sort of sorted already in the storage on the user. So that means that it can really quickly find this slice of data, and of course it's a lot cheaper. You can create these partitions on 3 different things. So the normal thing that you do is that you actually create it on a date. So you create, 1 partition per day. But there is also like a limit. So you can only have 4,000 partitions in a table. So that means that, what is it, like 4,000 days, like 5 years of data. So that also limits you in that sense. And you can't sort of put the data, back in time. So if you have it partitioned on a date, and then you have a row that is maybe a year old, you can't insert that anymore, because they are sort of locking down, as the time progresses. But there is a really powerful one as well, that you can create an integer one. So you can sort of decide yourself that you want to have a partition, maybe the number 1 to 4,000, and then you can create your own hash or some kind of calculation to sort of put the data into a specific partition. So that's also a pretty new feature, but it's quite powerful. So then you can do, as in this example, you can use it on the customer ID. So then it can put customers with similar IDs in the same partitions to make it a lot cheaper. And then we had sort of the last layer, and this is the BI engine. So it's really powerful. Google has like really good YouTube videos where they deep dive into this BI engine. From a user perspective, you can't really change anything about it. You enable BI engine, and you sort of select how many gigabytes of data, like cache, you want to have, and then you pay for that. So maybe you pick like 10 gigabytes of cache in memory, and then Google will try and sort of analyze the queries you're making and sort of analyze the data and see sort of how you're making the joins, which data is sort of used together, and then it will sort of populate this memory and try to optimize it as best as possible. But as a user, you can't really tweak it, so you sort of have to rely on Google's sort of guesses. The good thing is that you pay for this BI engine sort of on a storage base. So if you pick 10 gigabytes, you're paying for that. And as long as your queries are hitting BI engine, you don't pay for anything more, because then the result is already sort of present in cache. So it's only when it has to go down in the layers and look into the sort of the clusters and the partitions, that's when you start paying for the processing power. So it's a really good way to just increase performance. You can get it down to 100 milliseconds instead of 10 seconds. So that means that you can work directly with Google's Data Studio or maybe Power BI or some other tool on top of it, and you can sort of work in real time with the data without having these penalties. Yeah, how are we on time? We have a bit more. Can go back to. I want to talk a little bit on the security side as well, because I see I have a few more minutes here. So Google takes like the privacy and security quite seriously. So one thing is, of course, they're following like all the different standards and compliances, but they're also working proactively. For example, now there is a new sort of agreement between the US and Europe that is sort of being put together to sort of work, to make it a bit more free to work with personal data in the cloud. But Google already anticipate that this also will be challenged and will be sort of fall. So they're trying to build sort of the platform and the tools sort of secure enough so they don't have to lean on any specific sort of agreement or standard. And it's also very interesting to see like all of the cloud vendors, they're very open with sort of these different sort of government and court orders and so on. This is a bit old, but we can see here, for example, that GCP, they haven't got a single request on this one in the Nordics. So it's quite interesting, and they only got like 22 globally, and they haven't released any data. So they have challenged all of these requests. Now this is, as I mentioned, a bit old, Now they've actually released the data in one instance, but not in the Nordics. And if we look at some of the other cloud vendors, they are also challenging almost every request, but they've also released some of this data. And a lot of that has to do that they're building like these layers of security. So even if there is a court order that tells them to sort of release the data, it's so difficult to get the data out of the platform because you have like all these different layers of security and encryption. So it becomes like very cost inhibited, like to get the data out of it. So that's like one of the ways that the cloud vendors work with this. And in BigQuery, there is a lot of different layers that you can put on top of it to make sure that you're compliant and that you are, secure with your data. The first one is that like all data in BigQuery is encrypted. So Google encrypts every data that's in REST. They encrypt all the data in transit that goes over the network. You can't disable this, so it's always there. What you can do is something called a CMEC, Customer Managed Encryption Key. So you can take possession of this key and you can manage it yourself. So you can rotate it and you also give Google access to use it, but you can also revoke it. So that's one way to increase the security one step more. It's also possible to put these keys outside of Google. If you're like really want to make sure that you have full control, you can actually put them in your on-prem data center. And then every time Google wants to decrypt something, they send you a request and they also send a key sort of justification. So they tell you that I want to access this key because of this reason. So that could be, for example, that there is a court order. And then you can decide, do you want to allow that or don't allow it? Another level is, of course, the normal identity and access management that you have in Google, because a BigQuery table is a resource. So that means that you can, control the access. So you can decide which users have access to this data and not. You also have something called an authorized view. So you can create a view in BigQuery. So maybe you have like a lot of sensitive data and you don't want to, give everybody access to all of the data. You can create a view on top of it, and then you can give people access to that view. So you can sort of add another layer of protection, and then in this view you can sort away like a lot of data that you don't want to have to give people access to. You also have a column level security. So all of these columns where the data is stored, you can also control the access on individual columns. So that's also like a really powerful thing. So maybe you had a column with people's addresses, for example. So then you can control that access like even tighter. And then there's also a row level security. So you can sort of create a policy for like which rows are you allowed to see. So that could be, for example, if you're a big organization and you have a lot of managers. So maybe the managers should see the performance of their team. So then you can control it on a row level. So when they go into BigQuery and make a query, they only see the data that are sort of tied to their team. So that's also really powerful. Another thing that several of the customers that we're working with have adopted is something called AEAD encryption. So that way you can encrypt the data in BigQuery, one step further. So you have the normal encryption that Google adds, but then you can add like an application level encryption. So what you normally do is that you create an encryption key for every customer. So every customer has their own sort of encryption key, and then you can encrypt their PII data with this sort of unique encryption key. And then you can also control the access to it. So maybe you have analysts in the company that should only work with, non-PII data. Then you don't give them access to this encryption key. So when they're looking into the data, they don't see this sensitive data. And another thing is that you can then use crypto shredding. So let's say that you sort of lose this customer, and then you need to deal with the right to be forgotten. So what you do then is you just delete this customer encryption key. So you don't have to scrub the data all over the place because you now deleted this customer key. So then like all the data is secure. And the last thing is to use data expiration. So you can control how long a specific data should be in the table. So maybe it's like really sensitive data, then you can have it automatically be deleted with time. And what we see usually is that you don't pick, a specific technology, but you use a combination of these ones. And that way we can feel like confident in having, sensitive data in the cloud. But a really interesting thing we've seen is that when you're new into the cloud, of course you want to put like the PII data in there, and because you always do that. But then when looking into it a bit more, you see that in a lot of cases you don't need to have the PII data there. Like it's just, just a bad habit, like from the old days. Usually you can put a token there, maybe you can, anonymize the data, and still, you don't need to know the name of, the person that shopped on your site. So yeah. Any quick questions before the pizza time?
Like with the crypto shredding, does that mean like the keys disappear, but is the data still there?
Yeah, exactly. So you encrypt. So it's sort of this, it will only appear as random data if you don't have the key. So that way you don't have to, find all this like customer data all over the place. If they want to be forgotten, maybe you have backups, and there's, a lot of work in doing that. But if you delete the key, the data becomes unreadable.
But like over time, isn't there going to be like a lot of unused, or like just random data that takes up space? Or
yeah, but a lot of times you still want to have it, because even if you can't read the PII data anymore, you can still aggregate on it. You can see that you had a customer. You don't know who it is anymore, but in the reports and everything, you can still get a lot of valuable data. So you can still, for example, see how many unique customers did you have a specific day. So it's still like really powerful. So that's it was a good question. I missed to explain that. So yeah, any more questions? And of course, we will be available during the mingle as well to answer any more questions you have on BigQuery. And if there is an interest, we also have some more of the security slides, and also a bit on the cost side.
I guess more is there any like black swan events? Because I mean, it's data storage and it's all over the world. But if there's I don't know, some sort of black swan event, there's a what do you call it, earthquake or something, and one facility goes down. How's the data secure then?
Yes, you can have, you can either pick a region. So when you're creating the table where you want to put the data, you can specify a specific region. For example, you want to have it in Finland. And then every region has usually 3 data centers. So you have a replication within the region. But you can also pick a multi-region. So then Google will, replicate it. Maybe you have it in Finland and in Belgium. So if one of those entire region goes down, so you still have the data available. So. Yes, is it pizza time? Perfect. I think it's good timing. Yes, and there will be, of course, a possibility after the pizza as well, if you stick around to ask more questions. Because BigQuery, this is just like a very, very high level look into what you can do in BigQuery.